We are recording again. And so, guys, we're going to talk about fractions, decimals, percents. We're going to do some percent problems. We're going to do a little bit with graphs, and then we'll call it a day, okay? So, um, fractions, decimals, percents. The one thing I really want to make sure everybody understands is, what does a percent mean? Excuse me, a percent means out of how much? Out of 100, right? So when they say 70%, that means 70 out of 100. When they say 6%, that means 6 out of 100. When they say 25.3%, that means 25.3 out of 100, okay? So I'm going to look through this first problem here, y'all. And the first thing I notice is at the top of the problem here, it says 100 adults, right? So we know we have 100 here. 100 adults were asked to name their favorite sport, and the results are shown in the circle graph. And the first part says, what sport was preferred by the most adults? So I'm going to look at that pie chart, y'all. What's the biggest piece of that pie? Football. Okay, so we know that football was the most preferred sport. What percent of people like football? 37%. We say, how do you know it's 37%? Because we asked 100 people, right? So that's why we can say it's 37%. Let me write it somewhere else because I'm probably going to need that space in a minute. Okay. Now, the second question says, what sport was preferred by the least number of adults? So what's the smallest piece of that pie? Volleyball, right? Okay. Volleyball. And what percent of people like volleyball? 3%, right? Okay. Now, the second one says, what percent of adults preferred football or soccer? So, y'all, I'm going to take the football piece, I'm going to take the soccer piece, and I'm going to add them together. Anybody know what 37 and 13 is? 50. So 50%, right, liked either football or soccer. Okay, and then it says, what percent of adults preferred either basketball or baseball? So we're going to take the basketball folks and we're going to take the baseball folks and we're going to add them together, and that's going to give us 35%, right? Okay, there we go. All right, so percent means out of how much again? Out of 100. Okay, so look, y'all, I want you to look at this next problem we have here. Again, remember, a lot of the problems on your test, y'all, are going to be multiple choice. That's why I'm trying to put multiple choice problems on here. It says a basketball player made 86 out of 100 attempted free throws. What percent did they make? 86 out of 100 would be 86%, right? Because it's out of how much? Out of 100. That's what a percent means, okay? So again, y'all, if it tells me out of 100, it's going to be real straightforward. Let's take a look at the problem over here. So I'm going to use that pie chart. It says a group of 100 adults were asked what type of cake was their favorite. The circle graph on the right shows the result. What percent preferred marble cake? So how many adults did we ask? 100, right? So we asked 100 adults, right? So we know that that number is going to be a percent. How many people like marble cake? 12. So what percent would it be? 12%, right? Again, I don't want you to get too boggled down with like, look, why did they give me a 1 over 12? Why did they give me a 3 over 25? Not important, right? It's out of 100, 12% liked it, or 12 people liked it, so it's 12%. Okay. Okay, so look, y'all, we're going to figure out now, how do I go from percents to fractions to decimals, all that kind of good stuff. Okay. So the way we change a percent to a fraction, remember, a percent means out of how much? Out of 100. Bless you. So look, 7%, bless you, says drop the percent sign. So we're going to get rid of the percent sign. So I'm going to do that. And place a number over how much? Because that's what a percent means. So look, 7 over 100. That's what 7% means. 7 out of 100, right? Express 150% as a fraction. Again, I'm going to get rid of the percent sign, and I'm going to write 150 over how much? Okay, y'all, now if I can reduce my fractions, I'll go ahead and do that. So when I look at this problem here, well, I can't make those numbers any smaller. But if we were going to reduce 150 and 100, one thing we could possibly do, let me see if I still have my multiplication table. Yep, here we go. Y'all, I want you to notice something. When I look at the numbers that I have, 150 and 100, they both end in a what? Okay, if I come back over here and I look at my chart, look at the tens. Don't they all end in what? In zeros. Okay, so look, let's do this. We know we can divide them by 10. So how many times does 10 go into 100? 10 times. How many times does 10 go into 150? 15 times, right? So look, y'all, we can come back over here. We can say, look, we're really dividing them both by 10. That's going to give me 15 over 10. Doesn't mean I'm done yet, but at least that's a place for me to start. Now, 15 and 10, if I come back, y'all, and I look at my chart again. Where's my chart? Here we go. 15 and 10, we can divide them both by how much? 5 goes into 10, and 5 goes into 15? 3 times, right? So look, we're going to say, look, we're going to divide them both by 5 now. And that's going to be 3 over 2. And there's my answer as a fraction. Y'all, for the most part, they do ask you to reduce your answers. So I wouldn't just want to leave it as 150 over 100, right? And if this was a multiple choice question, more than likely that would not be one of my choices. But I wouldn't want you to like start freaking out. Why is it not one of my choices? Because I got to keep breaking the numbers down a little bit, okay? Y'all, in a minute, before we leave for the day, since we all got this calculator, I want to say, and again, the only thing I can tell y'all is when you're taking your test, I don't know that every single problem is going to have a more advanced calculator. And if it doesn't, then, but I'm going to show you how you can do that same problem on the calculator and it'll give you the same answer, okay? All right, let's come back over here. How are we going to change a percent to a decimal? We're going to divide the number by 100 and we're going to drop the percent sign. Okay, so look, first thing here, I have 38. First thing I'm going to do, y'all, 38, and I'm going to divide it by how much? 100. Let's take 38 divided by 100. Boom, 0.38. And we're going to do what with a percent sign? Drop it. Drop it like it's hot, right? So look, there it is, 0.38. That's all I got to do. I'm going to do the same thing for this one here, y'all. Look, I'm going to take my calculator, 175. Yep, we're going to divide it by 100, 1.75. Yo, when we're dividing by 100, the other thing that we're really doing here is we're moving our decimal point. Okay, if you don't see the decimal point is always understood to be at the end. What we're doing it is we're moving it 2 spaces to the left. We're moving it that way. So look, it's right here. We're going to go 1, 2. We're going to put it in front of the 3. Okay. The decimal point was right here. I'm going to move it 1, 2, put it between the 1 and the 7. Okay. Look, y'all, I can do the same thing here. If you don't want to mess with the calculator, the decimal point's right here. I'm going to move it 1. I'm going to move it 2. If I move it 2, what do I think I got to put there? A 0, right? So 0.04. Now, if you say, you know what? I don't like doing it like that. Okay, take 4 divided by 100, 0.04. There it is, right? Which way do you like to do it? It's up to you. You're going to get the same answer. I'm going to move my decimal point, y'all, 2 spaces, 1, 2. So I got to put a 0 there, 0.052, right? Again, if you don't like doing it that way, take your calculator, 5.2 divided by 100, 0.052, right? Same thing. Okay. Now, how do we go backwards? We're going to multiply by 100 and we're going to add the percent sign. Okay. So look, I'm going to do the same thing here. I'm going to multiply this number by 100. Okay, so look, let me take my calculator. Let me clear this out. 0.27 times 100 is what number? Just 27, and we're going to add the percent sign.
So in this case, we just move the decimal to the right.
There you go. Very good. So look, guys, we're taking our decimal point, and we're going to go 2 spaces, but which way? To the right. Right? So look, it's right here. 1, 2, behind the 7. There it is. I'm going to do the same thing here, y'all. Look, 1, 2, behind the 9. Okay. I'm going to do the same thing here, y'all. Look, 1, 2. If I put it here, what do you think I got to put there? A 0. 320%. And if you say, I don't like doing it like that, I want to use my calculator. Go ahead and use your calculator. 3.2 times 100. 320. You get the same answer, right? What do you want to do? It's up to you. If you feel like, you know what, I want to really make sure I get it right, I'm going to use my calculator every single time, hey, do it. If you say, you know what, I know how to move my decimal point, do it. You're going to get the same answer every time, right? So 140%, right? Yeah, the only thing is that when you take the test, the calculator will be on the computer itself. So you're not going to walk in. Yeah, you won't walk in with that, but you're doing the same thing. Notice the calculator I'm using, right? That's what you're going to see, right? And it'll pop up. And then if their problem is a little bit more advanced, then they'll give you a more advanced calculator, right? Where you might have to do exponents and stuff like that. And we'll talk about exponents a little later. Okay, so let's take a look here, y'all. How do we write fractions as decimals? All we got to do, we're going to use our calculator for these. All we're going to do, y'all, we're going to divide. So look, first one is 1 over 4. So people ask me, is it always going to be like this? Every single time, y'all. I'm going to take 1, I'm going to divide it by 4. I always take the top number, divide it by the bottom number. 0.25, right? 0.25. Okay. I'm going to do the same thing here. Look, 4 and divide it by 5. 0.8. Okay. Look, we're going to take 3 and divide it by 8. 0.375. Okay. One more, y'all. I'm going to take 23 and I'm going to divide it by what? By 4. 5.75. And people say, you do like that every time? Every single time, y'all. You always take the top number and divide it by the bottom. Guys, the one thing I'll tell you what I like about math, it never changes. Like, what is 5 times 5? It's always been 25. It's always going to be 25. When I'm dead and gone, it's still going to be 25. 100 years ago, it was still 25, right? If I were to ask you today, does anybody know who the Secretary of State is for the United States? Anybody know? I don't know either, but I could Google it, right? But doesn't the Secretary of State change based on whoever the president is, right? Because okay, so who's the Secretary of State? Pues quién sabe? I don't know right now. I got to look it up, right? Or if I were to ask you, do y'all know who the current vice president is? Kamala Harris. Do you remember who it was before? Who was the vice president before? Before Mike Pence, right? Who was the vice president before that? Joe Biden, right? Because that's when Obama was president. Okay, do y'all remember who the president was before Obama came in? George W. Bush. Okay, do you remember who his vice president was? Right? You see what I mean? It changes, right? But if I ask you, what's 5 times 5? You're going to say it's. And if I ask you tomorrow, it's going to still be. You never have to worry about it, right? That's the nice thing about math. It never changes. She was no, she was Speaker of the House. Yeah. But you see what I mean though? Those things change, right? Look, y'all. Okay, I guess I copied the same problems twice. Oh, this one says no. This one says, okay, sorry. This one says change it to a what? Okay, I remember why I did this now. Okay, look, guys, didn't we already change them to decimals? Do we know how to change decimals to percents? We're going to take that decimal point and we're going to go what? 2 spaces. Wouldn't that be 25%, right? If we go 1, 2, very good. 80%. If we go 1, 2, 37.5%. If we go 1, 2, 575%, right? There we go, right? So again, we do it in stages, right? We go from a fraction to a decimal to a percent. Okay. Good, good, good. Excellent, y'all. Okay, again, we've already kind of done some of these before, but we're just going to do a handful more. Let's see, 40%. Remember what a percent means? It means out of how much? Out of 100, right? So look what it says. Write each percent as a fraction. Simplify if we can. 40%. 40%, y'all, would be 40 out of 100. Okay, the question I want to ask you all is, can I divide them at least by 10? Okay, so let's divide them by 10 because they both end in a 0. So now that gives me a 4 over 10. What do you think 4 and 10 can be divided by? 2. Let's divide them both by 2. What's half of 4? 2. What's half of 10? There you go. Now you're done, right? Okay, 125%. Remember, y'all, this is going to be 125 over how much? 100. Y'all, I want you to think about money. When you were a kid and you would play with change or you had a piggy bank or whatever, think about quarters. If you had $1.25, how many quarters would you have? 5 quarters, right? I'm dividing it by 25, but I'm thinking about it in terms of quarters. If I had $1, how many quarters would I have? 4. And there you go. And all we did is divide them by 25. But if you think about it in terms of quarters, does that make sense? Because when you were a kid, didn't you ever take your quarters, start putting like this? Oh, look, 5 quarters is $1.25. Okay, look, y'all, I'm going to do this next one here. I'm going to kind of do it on the side because I didn't give myself enough space. I'm sorry? I just didn't hear you. 3 quarters would be 75 cents, right? Right. Yeah, because yeah, I've got to think of the same number, right? Look, y'all, 1.9%. Would y'all agree I could write this as 1.9 over how much? Over 100, right? Okay, this is the only thing. We don't like to have decimals and fractions mixed up together. All I want to do is I want to make this number so that it's not a decimal anymore. Would you agree I only need to move it one time? Because if I move it just one time, now what number do I have on the top? I don't have a decimal anymore, right? But if I move this one over 1, y'all, I got to move that one over 1 too, right? Whatever I do to the top number, I got to do it to the bottom one as well. So if I move this one over 1 space, that gives me 19. What number would I now have here? 1,000, right? Now, sometimes you'll say, why didn't you move it 2? I thought you were moving everything 2. Well, just to get rid of the decimal, I really only needed to move it 1, right? But let me show you one more problem before we go on to the next one. If I had something like, I don't know, 2.17%, right? Wouldn't we say this would be 2.17 over what? 100? Now, to get rid of this decimal, how many spaces do I need to move that one? 2. Would I have 217? But if I move this one over to, y'all, I got to move that one over 2. How many more zeros am I going to put on the bottom now? 2, right? So if I move the top one over 2, I'll move the bottom one over 2. If I only need to move the top one 1, I'm only going to move the bottom one 1. Think about it like Christmas Day. If you have 2 kids and you give one of your kids one present on Christmas Day, you can't give the other one 7, right? You can't do that, right? If you give this one, well, so they're going to be all mad, right? But if you give this kid 2 presents on Christmas Day, you got to give that kid 2 presents on Christmas Day, right? Think about it the same way. Whatever you do to the top, do the same thing to the bottom. Okay, guys, we're going to come back to the 33 and 1/3 in a minute. Let's do these next 2 first, okay? 19 over 1,000, yeah. So look, let's do the next 2. We'll come back to the 33 and 1/3 once we do these 2 here. 400%. Everybody agree? 400 over how much? 100. Anybody know what's 400 divided by 100? 4. Boom. Nice and pretty, right? 400 divided by 100 is 4. Okay, let's do the same thing here. 275 over 100. Okay, y'all, I'm going to think about this again. I'm going to go back to quarters. I'm going to think about dividing them by 25 cents. So how many quarters go into $1? 4. Okay, I'm going to use my calculator for the top one, but if I have $2.75, how many quarters would I need? 11 quarters, right? So there's that part there. Okay, so now let me go ahead and do this guy right here. Okay, so do y'all remember something called mixed numbers? Okay, so that right there, the 33 and 1/3 is a mixed number. A mixed number, y'all, is a whole number with a fraction. If you go home this afternoon and you decide, you know what, I want to make empanadas. What do I need? I need 4.5 cups of flour, right? That's what we call a mixed number, right? If you decide, you know what, I want to barbecue tomorrow. I need 3.5 pounds of fajitas. That's a mixed number, right? So how do I change a mixed number to an improper fraction? We take the bottom number and we multiply it by the whole number part. Can anybody tell me what's 3 times 33? But if we multiply, 99. I got 99 problems. And then I'm going to add the number on the top. So 3 times 33 is 99. 99 plus 1 gives me how much? This is 100 over 3. Okay. This is still as a percent. Okay. All we did, y'all, is change 33 and 1/3 to 100 divided by 3. Okay. Remember what a percent means? A percent means out of how much? Out of 100. Okay. So look, we're going to go like this. 100 over 3. Instead of me dividing by 100, y'all, I'm going to multiply by what we call the reciprocal, which is just putting the 100 on the bottom, but keeping a 1 on the top. Okay. Now, if I were to go straight across, 100 times 1 is 100. 3 times 100 is 300. Okay, guys, do you think we could cancel this 0 and that 0? Do you think we could cancel this 0 and that 0? So what would we end up with? And then you're done, right? Where was the 100 right here? It's it's still, yeah, very good. It's an excellent question. Her question, doesn't the 100 have to be on the bottom? It is, y'all. All we're doing is we're saying, look, instead of me putting the 100 on the bottom, like instead of going like this, because that right there, you say, oh man, that doesn't look pretty. If you remember, again, this is just if you remember. If you remember, the way we divide fractions is we multiply by the reciprocal. The reciprocal means take this guy right here and flip it. What I mean by flip it, you can think of this as being over 1, put the 1 on the top, put the 100 on the bottom, and instead of dividing, now we multiply, and you get the same thing. But I want to make certain that the 100 is still where? On the bottom. Very good. Excellent question, y'all. Okay. Now, guys, if it got a little confusing, I hope it didn't, but if it did, I don't want you to worry about it. Oh man, I'm going to fail the test because I can't do that one problem. You'll be able to do it, right? Just go slow, right? Change it. What do we do first? Mixed number to an improper fraction, and then we put a 1 over 100, right? The 100 is still on the bottom. Okay. Yes, ma'am. Uh-huh. Go ahead. Uh-huh. On the 275 and 100? Uh-huh. Okay. Yeah, so you can, okay, guys, so her question is, why did you decide to divide by 25? And one of her other teachers said, why don't you go with a smaller number? So a smaller number would be dividing it, say, by 5, right? I can do that. The only thing it's going to do, it's going to take me longer to get there. I'm going to have to do more steps, right? Y'all, when I think about, I'll put it this way. If I see like 25, 75, 50, 100, yeah, I think about the fact that those are increments of quarters. You know what I mean? Like 25 cents, 50 cents, 75 cents, or if they're double zeros. I say those are increments of quarters, right? Like 4 quarters, 1 with 2 zeros, right? 8 quarters, 2 with 2 zeros. It's not that we can't do it that way. We could. So guys, I'm just gonna show you another way of doing this. Her teacher said, look, instead of going big like 25, go small, go by 5. Okay, so look, we could do that. We could take 275, we could divide it by 5, we get 55. We could take 100 divided by 5, and we would get 20. And then we'd say, look, can we divide that by 5 again? Claro que sí, right? 5 goes into 55, how many times? And 5 goes into 20, and you get the same thing. Now, it's not a bad way to do it. It's actually a good way to do it. And I usually do that. But if I see that I can go with a quarter, I'm going to go with a bigger. If I can see it, right? If I can't, I'm going to stick with small numbers because I'm still going to get there. I'm still going to get to the same answer. Yes, ma'am. You had a question for me too? Yeah, over here. Okay, excellent question. We're going to multiply. We're going to take the bottom number times the whole number part, right? So 3 times 33 is 99, and then we're going to add one more. Does that make sense? So 3 times 33 is how much? 99. And then I have to add the number on top. And that's how I got 100. But I still keep the 3 on the bottom. Yeah, so think about it this way. Let me see. I'm trying to think how many people in here. I'm just going to make it up, y'all. I'm going to make it up. I'm going to say that there are 29 of you here. What time did we get out of class today? 1 o'clock. My guess is when you get out of here, what are you going to go do? You're going to go eat, right? Guys, if I told you in the parking lot, I have my barbecue pit and I don't want you to go home hungry. So I'm making you hamburgers today. And I don't want you to, like, I don't want to make you a little McDonald's 39-cent burger, right? I'm making you big burgers. I'm making you burgers that are half a pound each, right? Okay. Now there's 29 of us here, y'all. Hold on, guys. Look, there's 20 guys. Hold on. Look, there's 29 of us here, right? If I'm going to make 29 burgers that are each half a pound, right? I have to go to the meat market and I say 29 times 1/2. Can I get 29 halves pounds of carne molida? And for the most part, they're going to say, what do you mean? Well, look, if I were to say, can I get 14.5 pounds? I want to show you that this number here, y'all, and that number there are the same number. What's 2 times 14? 28. What's 28 plus one more? That's what that means. 14.5 pounds means I need 29 burgers that are each how much? Half a pound, right? But when we go to the meat market, we never tell the guy, can you give me 29 half pounds? We say, can we get 14.5 pounds, right? But that's really what it means because you're taking the 2 times the 14 and then you add the extra one that you got on top. But that's basically how you go from a mixed number down here to an improper fraction. Now, just to show you, how would you go backwards? You would take 29 and you would divide it by how much? Okay, and you say, okay, well, how do I do that, right? I want you to look at your chart. Let me see. Here we go. Here's my 2, y'all. I'm trying to get 2 into what number again? Okay, I want to use my chart. What's the first number in the 2s that's closest to 29 without going over? 28. How many times does that go in? Okay, so look, we're going to come back here. We're going to say that's 14 because that's 28. What's my remainder? So my answer is 14. 14, the remainder on top, whatever number I was dividing by goes to the bottom, right? Now, again, y'all, the reason why I show you a lot of the stuff with the table is it's been my experience in the last, I would definitely say 10 years. A lot of people, either they weren't taught with the table, maybe you were taught using other methods, and whether those methods are good or not, I think there's debate about it. I think some of them are really good. I think some need some practice. But what I've noticed is that people often a lot of times forget how to do this stuff. And using the chart, you can see how simple it can be, right? And again, look, guys, I mean, I'm all for technology. I got an iPad, right? A lot of my classes, one of the things that I do, I'm just going to pull this up real quick just to show you all. But I don't want to take too much time because I do want to finish what we got to do. Is I have this app. It looks like a big graphing calculator, right? Last year, y'all, I'm going to tell you now because now the other people left. Last year when they came, they didn't give you this little $11 calculator. They gave them graphing calculators. They were like $100, right? So you know what a bunch of my students did? They put them up on OfferUp and Marketplace and stuff like that because they're like, I'm not going to need this calculator. So they made $100 coming to the class, right? But my point being though is that this calculator, right? So if you were to go buy one of those calculators, the graphing calculators at Walmart or Target, they're like $100, $125. This app, you can get it on your iPad, iPhone, Androids. It doesn't really matter. There's a bunch of them. Some of them are free. The free ones sometimes have ads and they don't have all the features. But if you pay for it, $6. It's cheap, right? Why am I going to spend $100 when I get something like this for $6, right? It does the same thing. I'm not against technology. I use it a lot. But I think sometimes knowing how to use this is a much better idea because I understand what it is I'm doing. Like when we said 2 into 29, so we said let's go to the 2, let's find the first number closest to 29 without going over. And it makes sense because I can see it. It's visual, right? So anyway, let me come back here, y'all. Let's keep working to finish up what we got to finish up because we got about an hour left, and I do want to make sure that we knock all this stuff out before the day is done. Uh-huh. Yeah, 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 14 and a half, the 1/3, it just stays there. Yeah. Okay, so look, y'all, let's do a couple more. We're going to write fractions as percents. So remember, we've already kind of done some of these before, right? So look, 9 over 20. Didn't the first thing we say we were going to do was take 9 and divide it by how much? 20. And I'm getting 0 point what? 0.45. How do I now change that to a percent? Move the decimal point 2 spaces over. Isn't that 45%? Okay. 2/3. Look, y'all, let's do the same thing here. 2 divided by 3. Whoa, look what we got. That's a decimal that goes on forever and it repeats, right? What number repeats? The 6. Okay. So look, this is usually what I tell my students to do. In these types of problems, y'all, they're always going to tell you to do a little bit of rounding. Okay. So look, just write a bunch of them. How many spaces do I need to move my decimal? Okay. So 66 with a bunch of them after that, right? However many you want to put, doesn't really make any difference. Okay. Now, they're always going to tell you to round. Suppose they told me to round to 1 decimal place. That would be the number that I'm going to round. Okay. So the way I would round this is I say, I got to look at the number to the right of it. And if the number to the right of it is a 5 or bigger, this guy has to get bumped up by 1. So this would be 66 point what? And there we go, right? And you don't have, so don't worry about like, do I write a 6 with a little bar? No, just write a bunch of them. Move your decimal over and then do what you got to do. Okay. Look, y'all, we did something like this a little while ago. Does anybody remember how would I change that mixed number to an improper fraction? 2 times what? Okay, so what's 2 times 1? 2. 2 plus 1 more? 3. 3 over 2. Okay, let's do that. What is 3 divided by 2? 1.5? Okay, now, do I got to move my decimal point? How many spaces? Which way? To the right. Look, 1, 2. If I do it here, what number is going to have to go there, y'all? 150%. There you go, right? Very good, y'all. Look, she says, look, isn't that really the same? Isn't a half the same thing as 0.5? So you can say, look, that's 1.5, and then go from here directly there, right? Very good. You got it. Okay. All right. Guys, I got another one here. It says, write 1/12 of the percent, round it to the nearest hundredths of a percent. Okay, so look, let's take 1 over 12. 1 divided by 12 is, okay, so look, I'm getting a 0.08 with a bunch of 3's, right? Like this. Okay, how many spaces are we going to move our decimal point? Okay, 1, 2. So would you guys agree 8 point with a bunch of 3's after that? Okay, now hundredths. So I want to talk a little bit about place values. Hundredths, y'all, is the second number. When you so forget about this for a second. Think about this number here in terms of money. Aren't those the pennies, right? How many pennies, bless you, how many pennies do you need to get $1? 100. That's why we call it the hundreds position. These are the dimes, right? How many dimes do you need to get it to $1? 10, right? That's why we call that the tenths position. Does that make sense? Right? Okay, now I know there's thousands and 10,000, but in terms of money, we don't have increments that small, right? We either do dimes or we do pennies. I know we got nickels, but in terms of place values. So this is the hundredths position. That's the number that I'm going to be rounding to. Okay. So I'm either going to leave that 3 alone or I'm going to bump it up. I got to look at the number to the right of it though. Since that number is 4 or smaller, y'all, I'm going to leave it alone, 8.33%. Now, if this number here would have been a 5, 6, 7, 8, or 9, then I would have written 8.34%. Does that make sense? Okay, good. Okay. So again, y'all, so this was a little bit over a year ago. I actually went and took the TSI-2 test myself as a student, just to kind of see what kind of questions that were on there, right? So when I made this booklet, what I tried to do, y'all, was from memory because I had taken the test maybe a month or so before. Was okay, what kind of stuff they put on there, and that's how I made my little book. Okay, look what it says here. What percent of the figure is shaded? My question to you: how many rectangles do we have in total? 8. Out of the 8 rectangles, how many are shaded? 3. So we're just going to take 3/8 and change it to a percent. So look, let's take 3, let's divide it by 8. 3/8 is 0.375, right? Okay, if I move my decimal 2 spaces over, y'all, 37.5%, which of those choices is my answer? C, right? Because isn't a half the same thing as 0.5 like you said a little while ago? There you go, right? Okay, let's do the same thing here for this next one, y'all. How many pieces of that pie do we got there? In total, 8. Good. In total, we have 8. How many of the 8 are shaded? So 5 divided by 8 is 0.625, which is 62.5%. A. Does that make sense? Yeah. Guys, are y'all feeling okay about what we're doing here? Okay, I just want to make sure we're good. Did I go too fast on that one or no? We're good? Okay. Okay, so y'all, the next part here is, again, percentages, y'all. There was a lot. I noticed when I took the test, there was a lot of percentage problems. Guys, the one thing I do want to say, the test is adaptive. What I mean by that is if you're getting the questions right, it's going to start to ask you harder and harder questions. Now, that doesn't mean we'll start getting a bunch of them wrong, right? It doesn't mean that, okay? It's better that you're getting the questions right. And if you get like the last 7 or 8 questions that are really hard, that's okay. But I don't want you to say, well, you know what, let me get this one wrong so it'll keep asking me simple questions, because then you're going to get those additional 40. But what I saw was a lot of percent problems. Okay, this is how I do my percent problems. There's different ways of doing it, but this is how I do mine. Anytime I see the word of tells me I'm going to multiply. Anytime I see the word is means what? Equals. Anytime I see the word what, that's going to be my unknown part. I can call it X, I can call it N, I can call it P. It doesn't make any difference, okay? So look, here's my first problem. It says translate and solve. Okay, 90.3. So the first thing I'm going to do, y'all, 90.3. What does the word is mean? Equals. When I see the word what percent, when I see the word what, that's going to be my unknown number. Y'all, I'm going to call it an N. And because what percent, I'm going to write N percent. Okay. What does the word of mean to do? Multiply. I'm going to multiply this by 42. Okay. Now, y'all, I'm trying to get the letter N by itself. Okay. So now, very good. Now we're going to divide both sides by the number 42, because if this is being multiplied, the way I undo it is to do the opposite by dividing. So look, let's go like this. 90.3 divided by 42 is 2.15 and percent. Okay, so y'all, I need to change this to a percent though. It's not a percent yet. This is a decimal. When we're going to go from a decimal to a percent, then we got to move our decimal point 2 spaces which way? To the right. 215% is my value of N. Is that one of my choices? Okay, guys, I want you to notice, look at what my choice B was. Yeah, but I have to change it to a percent. So all I want you to do is be aware, be careful, right? I want to say that you have unlimited time for the test. Guys, I would much rather you spend an extra 30 minutes taking your test and pass it than saying, well, you know what? My cousin called me and they want to go do this at 11, so I'm going to try to hurry up because that's not going to do any good, right? So take your time with it, okay? I'm sorry? Because I had a decimal and I need to change that decimal to a percent. Remember how we changed those to a percent? We got to move it to the right. Do you do? It'll work the way you do too. You do yours with fractions. And you get the same answer. Without moving the decimal point, it's going to work too. It's doing it, yeah. It's doing it as a proportion. That works too. Well, it can be. It can still be a. It can still be a. You can still have a percent that's a decimal. But if once you do your first step, if it's telling you to write it as a percent, we haven't moved my decimal place yet, right? Because I have a decimal answer. If it tells me to write it as a percent, then I got to move that over 2 spaces, right? So look, y'all, I'm going to do the same thing here. What percent of 18 is 360? So look, first thing I'm going to write, when I see what percent, I'm going to write and percent of. Of means times. 18 is 18. Is means equals 360. Okay, so look, y'all, I want to get the n by itself. I'm going to divide everything by 18. So I'm going to take 360 divided by 18 is 20, right? Okay, now I need to change that to a percent. So I got to move my decimal 2 spaces over. Don't I got to add 2 more zeros? 2000%. Is that one of my choices? There it is, right? Okay, I got one more like this, y'all. What percent of 20 is 2? Again, when I see what percent, I'm going to write n percent. What does the word of mean to do? Multiply by 20. What does the word is mean? Equals 2. Okay, look, let's divide it by 20. So yeah, 2 divided by 20 is 0.1. Okay, 0.1. Remember, guys, I got to change that to a percent. So I got to move my decimal point 2 spaces which way? To the right. Isn't that 10%? There's my answer. Okay. Let me keep scrolling down here, y'all. Look, I'm going to do the same thing with a lot of these problems. Y'all, when I want you to notice in the first 3 problems we did, we were looking for the percent. And you might say, how do you know you're looking for the percent? Because all of them said what percent, right? So all of them were saying what percent. So if you notice, we had 215%, we had 2000%, we got 10%, right? Okay, in these problems, we're not looking for the percent because they're giving me the percent there. Okay, so y'all, with these problems, what I'm going to do is if I see a percent, I'm going to write the percent as a decimal. So if I see 75% as a decimal, how would I write that? 0.75. Do y'all remember what the word of means to do? Multiply. Multiply in this case by 192. Do y'all remember what the word is means? Equals, I'm going to call what number n? Okay, all I got to do here, y'all, is take my calculator and multiply. 0.75 times, what is it, 192? 144? Is that one of my choices? There it is. Okay. Guys, the hardest thing I think in doing these problems is just making sure that when you write your percent as a decimal, that you write it correctly. Let me ask you a question. So look, let's do the next one. We're going to go through it real slow. First thing I'm going to write down, y'all, is 24 because that's the number that I see. Do y'all remember what the word is means? Equals. Does anybody know how would you write 4% as a decimal? 0.04. Very good, y'all. 0.04. A lot of times people want to write 0.4. Remember, it's 2 spaces, right? So if here's the 4, right? I don't know what it looks like. Yeah, maybe like this. I don't know. Anyway, if here's the 4, right? Here's my decimal. 1, 2. There's a spacer. I got to put the 0. Okay, what did we say the word of means to do? Multiply. When I see the word what, I'm going to call it an N or P or Q, doesn't matter. How do I get rid of the 0.4? If it's being multiplied, what's the opposite? Divide. Okay, so look, let's come back here. 24 divided by 0.4, 600. Is that one of my choices?
Yes.
There it is. Okay. All right. The next one here, y'all, says 20% of what number is 76? How would I write 20% as a decimal? 0.20. Perfect. Of means to multiply, right? When I see the word what number, I'm going to call it an N. Is means 76. How do I get rid of the 0.20? Divide it. Again, y'all, there's different ways of doing these. Some people have been taught to do this using like a proportion or using fractions. And by all means, if that works for you, that's what I want you to do. 380. Okay. My point is that there's multiple ways of doing these problems, and whatever way you find or you have already learned, if that works for you, I want you to keep doing that. Okay. As long as you're coming up with the right answers, there's multiple ways of doing the problems, and whichever way is easier is how I want you all to do it. Okay. Let's take a look here, y'all. Patricia got 56 out of the 77 questions right on last Monday's test. What percent of the test did she do correctly? Okay, can we write a fraction here? What's the total? Very good. How many did she get right? 56. Okay, what am I going to do first, y'all? Okay, so let's take a look. What should we? Okay, well, hold on. Can we do this? Can we change that fraction to a decimal? So would I go 56 divided by how much? 77? Okay, so look what I'm coming up with, y'all. 0.72727272, right? Okay, so 0.727272. Okay, that's a decimal. If I wanted to write it as a percent, I got to move my decimal point 2 spaces which way? To the right, right? Okay, so that would give me 72.7272, so on, so on, and so forth, percent, right? Look what it tells me to do. Round to the nearest what? Whole number. Okay, whole number, y'all, means we're going to round that guy. So would 72.7272, would it be closer to 72 or would it be closer to 73? Is that one of my choices? There it is. Right? Because of the 7. That's right. Because the number to the right of the 2 is 5 or more, then that 2 gets bumped up, right? Okay, let's take a look, y'all. Last year, Lee bought a share of stock for $9.40. She was paid a dividend of $5.64. Determine what percent of the stock price is the dividend. Okay, let's see if we can write a fraction. What was the total amount that she paid? $9.40. Okay. They paid her $5 and how much? Okay. Can we do this problem the same way we did the other one? Can we take that fraction and write it as a decimal? Okay. Guys, I know what we have. I know you could say, well, look, should I move that one over 2? Can I move that one over 2? You can. But since I'm using my calculator, I'm not going to sweat it. Look, 5.64 divided by 9.40. Okay, look what I'm coming up with, 0.6. Okay, this is my answer as a decimal. How would I change that now to a percent? 2 spaces, 60%. Is that one of my choices? There it is. Okay. All right, let me get a little bit of water because my voice is going out a little bit. Okay, says the Witcher family paid 17% of the purchase price of a $158,000 home as a down payment. Determine the amount of the down payment, round to the nearest cent. Okay, 17%, y'all. Can I write that as a decimal? How would I write it as a decimal? 0.17. Do y'all remember what does the word of mean to do? Almost. Multiply. Multiply by the price of the home. How much was that house costing us? 158,000. Okay, so look, guys, I'm going to take my calculator here. 0.17 times 158, 1, 2, 3. And I'm coming up with 26,860. Is that one of my choices? And there we go. That's how much they paid in regards to their down payment. Okay, guys, let me ask you another one. Here's the next one. 30% of the students in the school are male. How would I write 30% as a decimal? 0.30. What does the word of mean to do again? Multiply. The number of students. How many students were there? 780. Okay, let me ask you a question. Look, 0.30 times 780 is 234. Boom, there we go. Y'all, I got a quick question for you. If 30% of the students are male, could you tell me what percent of the students are female? 70%, right? Like, y'all know what's going to happen this weekend? We're supposed to get a bunch of what? Rain, right? So if you watch Tim Smith tonight, and in addition to you telling you how much what the chances of rain are, he gets mad at you because you don't know where Mission McAllen are, all that kind of stuff, right? But if he says, look, we got a 30% chance of rain tonight, that means that we have a 70% chance that it doesn't. Does that make sense? Right?
Which number does it?
Huh?
Which number does it? It's like 30%.
It's the rest of it, right? So what would be the rest of it? 100% minus whatever number I originally had, right? So we said 30% of the students are male, then 100% minus 30, 70% would be female. Does that make sense? Right? Or if he says there's an 80% chance it's going to rain tonight, 100 minus 80, that means there's a 20% chance that it's not going to rain. Does that make sense? Okay, good. Okay, let's take a look, y'all. Richard has $65.62 deducted from his monthly salary of $1,930 for a vacation savings plan. What percent of Richard's salary is withheld? And what percent of Richard's salary is not withheld? Okay, so let's take a look. What is his monthly salary? Do we know? $1,930. How much money do they hold out of that $1,930? 65.62. Okay, look, guys, let's change this to a percent. So first, we have a fraction. We're going to go from a fraction to a decimal. 65.62 divided by 1930 is 0.034. Oops, 34. If I change that to a percent, wouldn't that be 3.4%? Okay, this is how much is withheld, right? 3.4% is withheld. So what would not be withheld? Well, we would say 100 minus 3.4, right? The rest of it, 96.6 is not withheld. What's my choice here? What's my right answer? D. Boom, there it is, right? Right, just like we said about Tim Smith, right? Whatever chance of rain, the rest of it is not. Okay. Okay. Next problem here says, in an office building, 16 offices are currently not being rented. This represents 5% of the total number of units. How many offices are in the building? Okay, so look, y'all. First thing I'm going to do, I see the number what? 16. Okay, what I want to mention here, the word represent, y'all, is the same thing as the word is. And do you remember what the word is means? Equals. 5% as a decimal. Do you remember how what 5% would be? 0.05. Okay, there we go. What did the word of mean to do? Multiply. The total number of units. I don't know how many units we have. I'm going to call that n. If I wanted to solve for n, if I wanted to get the n by itself, and it's being multiplied by 0.05, what would I have to do? There you go. Y'all, I could have stayed home today. Y'all already know what to do. Let's take 16 and divide it by 0.05. 320. Is that one of my choices? There it is. Y'all, as we go through these problems and we find that whatever answer we get happens to be one of our choices, I hope you get like a nice warm feeling right here, like, okay, we're doing this the right way, right? If I wasn't getting that, if all the answers were like, that's not one of my choices, but then I would say, okay, I'm doing something wrong, right? But so far, we know what we got here is going on. Look, y'all, the next one here says the enrollment at a local college decreased by 3% over last year's enrollment of 1,900. Find the decrease in enrollment. Okay, so it says it decreased by 3%, right? Okay, 3% as a decimal would be how much? 0.03. Look what it says here, y'all. I see the word of. What does of mean to do? It means to multiply. So we're going to multiply by what number? There you go. 57? Okay. Is that one of my choices? There you go. Okay. Now, y'all, it was just asking me how many students left, right? Didn't ask me how many students are left or are still there. It just asked me how many left. Now, this question says the enrollment at a local college decreased by 9% over last year's enrollment of 2,700. Find the current enrollment. Okay, we're going to go about this the same way, y'all. First thing is 9% as a decimal, 0.09, right? Of means to multiply by 2,700. Let's do that part. 0.09 times 2,700 is 243. Y'all, that's how many people left the school, right? If that's how many people left the school, they want to know what's the current enrollment, meaning how many people are still there. How many people did we used to have before? There you go. We used to have 2,700, but 243 of them graduated or whatever. They didn't come back. Let's figure out how many is left over. 2457? Is that one of my choices? There it is. Boom. Okay. Question, y'all. Why did we subtract? But why didn't we add? Is my question. It was a decrease, right? It was a decrease. Decrease means it went what? Down, right? Y'all, look at the next problem. It's not a decrease, it's a what? So what do you think we're going to do here? There you go. Look, 5.9%. Okay, first thing is, how would I write 5.9%, y'all, as a decimal? 0.059. Perfect. We're going to multiply that by what? 35,440, right? So let's do that part. Let's come back over here. 0.059 times 35,440. Okay, so I'm coming up, excuse me, with 2,090.96. Okay, determine the new salary. So we want to know, so this is how much their salary is going to increase by, but now we want to know what their new salary is going to be. Wouldn't we take this number and add it to the 35,440? And $37,530.96. What choice is that? A. There we go. Okay. I got another problem, y'all, similar to the one we just did. Last year, the profit for the company was 134,000. This year's profit did what? Decreased by 2.7%. Okay, so let's do this, y'all. 0.027 times 134,000, right? 3618. But this was a what? A decrease, which means we're going to do what? Subtract it, right? Awesome. $133.82. There we go. Yo, one thing I want to mention here. If the problem would have said increase, the only thing we would have done differently is we would have done what? We would have added it, right? But the way we would find that amount would still be the same way, right? We'd still take the percentage times whatever the amount they gave me. And if it's a decrease, we subtract it. If it's an increase, we're going to add it in. Okay. Let's take a look here, y'all. The problem here says for each food described, find the percent of total calories from fat. If necessary, round to the nearest tenth of a percent. Okay, find the percent of total calories from fat. Okay, guys, let me ask you a question. Let's see if we can do this with a fraction. Do we know how many calories we have total? What's the total calories here? Looks like we got ranch dressing, right? 40 calories total? Out of those 40, how many came from fat? 20. This is the fat part, right? Okay, look, let's do this. 20 divided by how much? 40 is what, 0.5? If I change that to a percent, I got to move my decimal point 2 spaces. Wouldn't that be 50%? Right? Okay. Look, y'all, I'm going to do the same thing here. I'm going to do the same thing with the next one. Remember, on the bottom is going to be my total calories. On the top is going to be my fat calories. Okay, do we know what our total calories are? 190. Out of those 190, how many of them came from fat? 130. Okay, let me just take my calculator. What's 130 divided by 190? Okay, look what I'm coming up with, right? Ugly number, right? Remember, we said we're going to move our decimal point 2 spaces over, right? You can move it 2 spaces over by multiplying by 100. 68.42 with all that kind of fun stuff, okay? Now, guys, I'm going to just kind of scooch this down right here. Look what it says. Round to the nearest what? Tenth. Okay. In case you forgot, remember, the tenth is the first one. So this 4 is the number that I'm looking to round. Now, I'm either going to leave it as a 4 or I'm going to bump it up to a 5 based on the number to the right of it. Now, if this guy is a 5 or bigger, this guy's going to get bumped up. If it's a 4 or smaller, it's going to stay the same. So what do you think we should do? Leave it alone. So 68.4 what? Percent, right? And there we go. Okay, so y'all, the next part that I have here dealing with percents is percents increase and decrease. What I found is there's an easier way to do these problems, and what I want you to do is just think about this for a minute. Bear with me. I know we've been here since 9. We just got about half an hour left, guys, and then we'll be done. Okay, look, I used to have, think about this in terms of money. I used to have $50. Now I have 80. How much more money did we get? 30. Okay, we're going to do this in stages, y'all. I used to have $8. Now I got 12. How much more money did I get? 4. Okay. Look, I used to have $65. Now I have 117. How much more money did I get? 52. Okay, guys, in case you're wondering, all we're doing here, 117 minus what? 65, 52. We got 52 more dollars. Okay. We used to have $68. Now we got 170. 102. Thank you so much. Okay. This is what we're going to do, y'all. The way we're going to find our percent increase, we're going to take each of these numbers and divide them by the original. I'm going to go 30 over 50. Okay. So look, 30 divided by 50 is 0.6, right? Which is the same thing as 60%. Okay. Look, y'all, we're going to take this number 4. We're going to divide it by 8. That should be 0.5, which is the same thing as 50%. Okay. Y'all, I'm going to keep playing the same game here. I'm going to take 52 divided by what number? 65. Always the original amount, y'all. 52 divided by 65, 0.8, which is 80%. And the last one, y'all, is going to be 102 divided by 68, 1.5. Isn't that 150%? Okay, that was increases. Now, why were they increases? Because the numbers went up. From 50, we went up to 80. From 8, we went up to 12, so on and so forth. Now, look at y'all. This part says amount of decrease and percent decrease. These numbers didn't go up, but they went how much? They went down? Okay, I want you to think about this for a minute, y'all. I used to have $8 and now I only have 6. How much money did I lose? 2. I used to have $25. Now I only have 20. How much did I lose? Good. I used to have $160. Man, now I only got 40. 120. Good. Excuse me. I used to have 200. Now I have 162. 38. Okay. We're going to take each of these numbers, y'all, and divide them always by my original amount. 2 divided by 8 should be a 0.25. As a percent would be what? 25%. Okay. 5 divided by 25 should be a 0.2. As a percent, okay, 120 over 160, which is the same thing as, there you go. And then finally, one more, y'all, 38 over 200 should be a 0.19 or, and there you go. Okay. Now, let me ask you a question. Did these problems make sense how we did them? Finding how much we had, how much either it went up by or went down by, so on and so forth, okay? Now, the reason I wanted to ask y'all if they made sense, I hope they made sense in the way we set it up. The reason being, y'all, look at the next problem. The next problem says there's 150 calories in a cup of whole milk, but there's only 84 calories in a cup of skim milk. In switching to skim milk, find the percent what? Decrease. Okay, look, let's do it like this. Before we were drinking whole milk. Now we said, new year, new me, I'm going to go to skim milk. I used to take 150 calories, but now we only get 84. How many calories did we save? Yeah, 150 minus 84, we saved 66 calories, right? Now, to find the percent decrease, what are we going to do? We're going to take 66 divided by 150. Same way we did before. We just made our own little chart, right? So look, y'all, divided by 150 is what? 0.44. Isn't that the same thing as 44%? There you go. Okay. Y'all, I got another problem very similar to this here. In 1940, the average size of a privately owned farm in the United States was 174 acres. In a recent year, the average of a privately owned farm in the United States had increased to 449. What is the percent increase? First question I had, is there a number in this problem that I'm not going to use?
1940.
1940, right? We don't need to know the year. It's not important. Okay. Before, we used to have 174 acres. Now we have how many? Okay. So the first thing we want to figure out the amount of increase. Okay. So let's take our calculator. 449 minus what? 174? Oops, I did something wrong. 449 minus 174 was 275, right? Okay. Now, y'all, to find my percent increase, I'm going to take 275 and I got to divide it by how much? 174, right? Okay, let's do this. Let's divide it by 174. Okay, again, I'm not getting a real pretty answer, but that's okay. Remember, we're going to move our decimal point 2 spaces over. Y'all remember the way you move it over 2 spaces? Just multiply it by 100. Okay, suppose I told you I wanted to round this to the nearest hundredths. Okay, remember the hundredths position, y'all? Is the second one, right? Because we need 100 pennies. Okay, so the 4 is the number that I'm thinking about rounding. In order for me to decide what I should do with that 4, I got to look to the number to the right of it. If this number is 5 or higher, that number is going to get bumped up by 1. So the fact that that is a 5 tells me that I should write 158.0 what? 0.05, right? Very good. Now, y'all, you might be asking me, like, sir, why did you decide to go to the hundredths position? I'm just pulling out random examples. When you're taking your test, it'll tell you, hey, round this to the nearest tenth, or it'll tell you round to the nearest hundredth. I just want to make sure that we know how to round and we know what each of those place values are. So tenths is the first one, hundredths is the second one, thousandths, y'all, would be the third one, 10,000ths would be the next one after that, so on and so forth. Okay, but I'm just trying to do random problems here. Okay, so we get the idea. Okay. All right. So again, y'all, I know after 3.5 hours, like we're all like, yeah, right? It's like I'm trying to fill up a cup, right? The water just kind of keeps flowing over, right? So again, I just want to finish up some of this stuff here, and then we'll pick up the rest of it on Monday. Guys, the one thing I do want to be, again, this is not about me. This is all about you, right? I'm here for you guys. Y'all have the ability to make any choices you want. What I would encourage you to do, y'all, Sunday night, you're getting ready for bed. I don't want you to say, you know what? I don't want to come back on Monday. Guys, it's 3 more days. Okay. So my thing to you, last year when we did this class, they waited until Monday. We went Monday, Tuesday, Wednesday, Thursday. This semester, they said, look, we're going to start on a Friday, and then we come back Monday, Tuesday, Wednesday. And part of that, having that break, I think it's easy to lose momentum, especially because those of y'all who are coming to school, anybody coming to school this last semester? Okay. When did your finals end? Yesterday. And we're here today, right? So there's not a lot of time off, right? Yesterday, all my stuff was due, right? So I finished all my grades last night, 8 o'clock, boom, I'm back here this morning, right? So what I'm just saying is it's easy to after today and you have the weekend like, I don't want to go back. Guys, it's 3 more days, okay? I would encourage you, keep coming back. I'd much rather you do that, spend the extra 3 days, increase the likelihood you pass, and then if you want to take the whole summer off or whatever, by all means do it, okay? All right. Sales tax and total price. So look, y'all, we got a couple of formulas here. Sales tax is the tax rate times the purchase price. The total price is going to be my purchase price plus my sales tax. Now, look, we've all gone to the store before, right? We've all gone to go buy something. And unless you're buying a gallon of milk or a loaf of bread or bananas, there's no tax, right? Everything else has tax on it. So we all know how this stuff works. But look what it tells me here in this problem. The tax rate is 6%. Find the tax on a microwave oven priced at $188. Okay, I just want to know what the tax. So look, y'all, I'm going to take the purchase price, sorry, and I'm going to multiply it by the tax rate. Well, the tax rate is 6%, but as a decimal, how would I write 6%? 0.06. Okay, so let's do it. Let's clear that out. 188 times 0.06. 11 something? 1128, right? Boom. We know how sales tax work, right? It's just like everyday math. You've gone to the store before. You know that if you go to Walmart, you want a microwave for $188, you got to have more than $188, right? Because you got to pay tax on it. Okay. Stereo system has a sale price or purchase price of 426. What's the total price if the tax rate is 8%? Okay, so look, y'all, first thing we're going to do, 426 times 0.08, right? 34.08. Okay, now since we are looking for the total price, right? What does that mean we're going to do? We're going to take this number here and add it to what? The 426. Let's do it to it. 426 plus $34.08. 460.08, right? Okay. There we go. Okay, now let's take a look at the next one, y'all. It says the sales tax on the purchase price of a truck is $3,234.51. If the tax rate was 8.3%, find the purchase price of the truck. Okay, I'm going to make sure we're clear what they're asking me to do. They said, look, this is how much taxes you're going to pay. This is the tax rate. They're asking me, what are they selling me the truck for? Okay, not including the taxes. So the way we find the taxes, $3,234.51, is we take the tax rate, which in this case, 8.3%, y'all, as a decimal, 0.083, times the purchase price of the truck. I don't know what it is. That's what I'm trying to find. So if I want to solve for the purchase price, I'm going to divide everything by the 0.083. Okay. So look, let me grab my calculator here. Let me take 32, 34, and 51 cents and divide it by 0.083. And I'm coming up with 38,970. Is that one of my choices? There it is. Boom. All right. The sales tax on the purchase price of a $6,800 used car is 374. Find the tax rate. Okay. So again, y'all, when I usually do these problems in my classes, I would always kind of write this part down right here. Sales tax is tax rate times purchase price, right? So I would put something like sales tax equals tax rate times purchase price, right? And I would say, look, the sales tax, look, they already gave me that number. The sales tax was how much? 374, right? Because it says the sales tax on a purchase of a $6,800 used car is 374. There's my tax, right? It's asking me to find the sales tax rate. I don't know what that is. I'm going to call it TR for tax rate. What was the price of the car? The car was 6,800, right? So I want to find this number. I want to find my tax rate. I'm going to divide it by 6,800. Okay. 374 divided by 6,800 is, so my tax rate is 0.055. So wouldn't my tax rate, y'all, be 5.5%? There you go. All right. The next one here says the sales tax on purchase of a futon is $24.25. If the tax rate is 5%, find the purchase price of the futon. Okay. So look, y'all, I'm going to use the same part right here. Sales tax equals tax rate times purchase price. And all I'm doing is I'm just using that little formula that we had there. Okay. And we know that our sales tax in this case was $24.25. We knew that our tax rate was 5%, but as a decimal, that would be 0.5. We're trying to find the purchase price. So I'm going to go ahead and divide this guy out by 0.05 to find our purchase price, right? So $24.25 divided by a 0.05, $485 is what I'm coming up with. And that's the purchase price of my futon. Okay. Okay, so guys, we just have a couple more problems to do here with discounts and sale prices. If we're not able to do the graph stuff today, guys, we'll just do it on Monday, okay? So I just want to make sure, I want to see if we can finish up at least this part here. Yeah, we might save the graph stuff till Monday. Okay, but let's take a look here, y'all. Discount and sales price. Sales price. The amount of the discount is the discount rate times the original price. Okay, this is what I want us to do in regards to this little table here, y'all. Let's do this. How would I write 10% as a decimal? Point what? 0.10, right? Okay. What about 20%? 0.20. Good. What about 50%? 0.50 and 40%? 0.40. Okay, look, y'all. This is what we're going to do. To find the amount of the discount, we're just going to multiply those numbers together. So look, let's take the first number, $89 times 0.10, $8.90, 8.9, right? Again, y'all, think about it in terms of money, $8.90, okay? Look, $74 times what? 0.20 is 14.80, okay? 196 and 50 cents times 0.50, 98.25, okay? One more, 110, oops, 0.60 times what, 0.40? $44.24. Okay, now, if we want to find our sale price, this is how much it used to cost. What are we going to do with that discount? Subtract it, right? It's a discount. We got to take it away, right? So look, y'all, I'm going to take $89 and I'm going to subtract how much? $8.90? $80.10, right? Okay, let's do that again. Let's take $74 minus $14.80, $59.20, right? Okay. Look, let's take 196 and 50 cents minus $98.25, and we still get 98, right? Because it's 50% off, right? Okay, and then $110.60 minus what? $44.24, 66 and what? 36 cents, right? Okay. Look, y'all, let's skip this one here. Let's do the multiple choice one. It's the same type of problem. A $2,600 designer dress is on sale, bless you, at 30% off. Find the discount. Okay, so look, we're going to take 2,600. We're going to multiply it by 0.30. 2,600 times 0.30, 780? Okay, so let me fix that. It looks messy. Okay, there we go. There's my choice, right? That's what the discount is. That's how much. That's not how much we pay. That's how much they're going to do what? Take off right from the price. Is that a lot of money for a dress? $2,600? Maybe, right? Depends on if you think it is or it isn't. Okay, commission, guys. Did anybody here know what commission is? Right? You're in sales. You're selling iPads. You get a percentage of how much you sell, right? Okay, so commission equals commission rate times the sales. So look, y'all, it says Rosie Davis Smith is a beauty consultant for home cosmetic business. She's paid a commission rate of 12.8%. Find her commission if she sold $1,638 in cosmetics last month. Okay, so we're going to take her sales, 1638. We're going to multiply it by her commission rate, which is a 0.128, right? If it's 12.8%, 0.128. $209. Guys, if I'm thinking about this in money, remember, we don't have anything smaller than pennies. Would I say 66 cents or 67 cents? 66, right? Because that number there is a 4, so I can't round it. 209.66. But what I want to point out is I know this is not a multiple choice question, but if it was, what I want to mention is that the 4 would not be one of my choices because we don't have anything smaller than pennies, right? So they might give me 209.66, they might give me 209.67, but they wouldn't have the one with a 4 there. Okay. So the only reason I bring it up is, again, I remember when I was teaching and we were using this book, a lot of people would say, sir, I'm putting the 4 and it's telling me it's wrong because there's nothing smaller than a penny, right? Let's see. A salesperson earned a commission of $3,575 for selling $32,500 worth of books. Find the commission rate. Okay, so look, y'all, I'm going to do this very much like the way we did the sales tax problem. They give me a little formula. Commission is commission rate times sales. So look, I'm going to zoom in. Commission equals commission rate times sales. Okay, this person earned a commission of $35.75. We don't know what the commission rate is, so I'm going to leave that alone. But we know that their sales were $32,500. Very good. So look, y'all, let's divide everything by $32,500. Okay. $35.75 divided by $32,500. 0.11, which is the same thing as what? 11%. Hold on. Okay, guys, we'll pick up on the pictographs, bar graphs, line graphs. We'll do that on Monday, okay? Guys, we should not have, they came to